Hello everyone, my name is Seper Hatami. I hope it's okay if I take this presentation in English. I come from Sverige AVF and I'm here to present this project called Additive Manufacturing of Complex Ceramic Cores for the precision casting industry. This is a small pre-study project where we want to see is it possible or not. It's within the framework of from prospecting to recycling call, Metalliska material. We have a total budget of 700,000 SEK. It's a 1-year period. And in this project we work, it's IVF and Ventana Hakos company. This is their new name. Before they were called Hakos Precision Uteri. So you might, they have had some reorganization. So there, in Hakos, in this small little town, they have a very advanced process. It's quite impressive, where they use precision casting using plaster molds. They make detailed aluminium components. They pour aluminium, and today their components can range between 10 grams to 78 kilos. When it comes to wall thickness, it's quite impressive. We heard about some previous casting talks before. I mean, 1.5 millimeter typical thickness if they want, and going up to down to 0.8 is truly, I think, impressive. When it comes to surface quality, once again you see RA of 1.6 or better, flatness 0.3 millimeter or better, and radii. These are, I just took these from their website, so here you can see these cooling fins, very detailed. I mean, these are the things that today, if you think of metal additive manufacturing, this is what, if you were given this component. But they can produce it very nicely. And this project is about casting cores, how to develop cores. And if you have cavities in casting, in your cast component, you need to fill it with a core, ceramic core, so that you get the empty space. In this slide, I want to show you the process steps they have. So they start with some simulation of the process. Then they do the preparation of mold making and the entire casting operation. The next step is that they make a pattern. They machine a pattern out of aluminium. This pattern is then placed inside the box, and the next step is they pour plaster. The plaster is then dried and heated at around 250-30 degrees for about a week. 2 minutes. And then it is assembled and then pour the melt. So if the core is weak, because they make the core also out of plaster, if the core is weak and things fail, all these steps are wasted. And of course, one would think that these are the most environmental critical steps, and also economical. Current core production, they machine a core box where they pour plaster inside. It's very flexible, it's very precise, high surface quality, but there are problems to it. The core can, since it's made of plaster, it can warp and fail. There is manual labor. This is done manually. They have to overfill the box, and plaster can be wasted, and drying times and so on. Even the core box, they need to store it. So they need to sometimes rent a room to store this, like a bookshelf. So what was our idea? We said, is it possible to, if you think of material, can we replace plaster with a stronger material? And in that case, our proposal is some sort of an engineering ceramics to increase the strength of the core. Can we replace the process by AM, which is, as we all know, it's hopefully less waste. We have in IVF a unique printer where we can print ceramic parts. I will skip that. This is the part we are focusing on. This is what we want to cast. It's a lamp holder. They are currently producing this, and we want to make a core. So far we are here, and through this process we realized that, okay, if we can print the core, why don't we print a pattern as well that they use for making the mold? And we made some parallel attempts to even manufacture the pattern with plastic. This is my last slide. So there are lots of things we don't know. This is just a try. And the process window is of course not established. The material is not optimized, perhaps. The strength of the core for the application, we will get to see this when they do the actual casting. And the core removal. Once you make the cast, you must be able to remove the core. So if it's too strong, it's not good either. And as I said, we try to make a pattern with plastic. And in that case, we understood that the conventional extrusion techniques are not good enough. So we will make a final attempt with another technique.
Thank you.
Thanks.
Do we have any questions to Surfer from the audience?
How big parts can you make with the current method? You have a size limitation on the core with the 3D printer.
Yes, that's it's not more than a visit card today. After, if of course it's being sintered and so on. But Hakos finds this something that is going to improve. So machine builders will hopefully make bigger platforms.
Thank you.
Mm?
Och med det